Welcome back to the mathsonlinetuition.com videos, where we're continuing with chapter 8, subsection 8.4. So you need to be able to recognize the graphs of sine, cos and tan. This is particularly important because it's going to enable you to work a lot faster when you're able to observe a graph and then extract its properties. If we refer to the sine graph, which is the first one that we're introduced to, I can make some key features. I can highlight some key features here, which is the fact that it starts at 0 when it comes to the y-axis. And this is important because there will be a differentiation between this with respect to the cos and the tan graph as well. And also you can appreciate that it starts, or at least the y range is from 1 and -1, okay, and it's periodic for every 360 degrees. So you can see that at 360 it continues again. So it's important to also appreciate that this is another way of writing that it's periodic. So theta plus 360 equals sine theta, and sine theta minus 360 degrees equals sine theta. And likewise, sine 90 degrees minus theta equals sine 90 degrees plus theta y, and that's because there's a symmetry about the theta equals 90. So here where theta equals 90, you can see on the right hand side you have exactly what is demonstrated on the left hand side. Now for the cos graph, the cos theta graph, you'll appreciate here that actually it intercepts the y-axis at 1. Now it still has the same range of 1 and -1, but now this time the symmetry is about 0. So you can see that there's symmetry at 0 theta. So you have this right side is symmetrical to the left side, and likewise here you can appreciate that it's periodic at 360 again, as is demonstrated here. So these are the two important properties you need to appreciate, along with the fact that the range for y is between 1 and -1, and it intersects at the 1 y coordinate point. Tan is slightly different in the sense that it's asymptote. You can see here that it intercepts at 0, 180, 360, so it repeats its cycle every 180 degrees, so its periodicity is 180. And again, this means that theta plus 180 degrees equals tan theta, and theta minus 180 degrees is equal to tan theta, because as we mentioned before, it is periodic. There's a small hint here that you should take note of. The dotted lines on the graph are called asymptotes, lines to which the curve approaches but never reaches. These occur at theta equals 2n plus 1, 90 degrees, where n is an integer. So these lines, okay, you can see, are the lines to which the curve approaches, alright, but they never actually intersect. And it also gives you the formula to appreciate formula to appreciate when you can find them. And so you have some examples here that go through questions asking you to sketch the graphs, and you can see they've just identically drawn out the graph from cos. Again here, now they've asked you to use radians, so you have to appreciate by looking back what conversion unit or rate is used from radians to degrees and vice versa. At 8.5, you need to be able to form simple transformations on graph of sine, cos and tan theta. This relates back to C1, where we did transformation of curves. Now remember that when we discussed transformation of curves, we went through some examples demonstrating how variables, when added, multiplied, can alter the look of the graph, or the position of the graph more so. And so here we're going to follow a similar principle. If you see that we have 3 sine x, so there's a scaling factor which is presented as a coefficient, and we enlarge our graph by a scale factor of 3 in the y direction. So remember what we said, that for sine it goes between 1 and -1. Well, you can see now with the 3 at the front, it starts, the range is between 3 and -3. And likewise for tan, you have a negative here, so what's happened is the fact that it's been reflected. The graph of the tan is in the theta x axis, so it's been reflected. We already discussed some of these points, and of course again right at the end there will be the summary of key points for you to appreciate these transformations and remember them, and a table will be very handy for yourself to create, simplify and condense all the information, and then to begin to compartmentalize it into your brain. And so here you can see that we have some addition, so sine theta plus a, cos theta plus a, and tan theta plus a. And you can see we have -1 here. So what's happened is that it's been shifted down. Okay, so in the 1 unit in the negative y direction. So if you recall, y for sine starts between 1 and -1, but here you can see it's been shifted between 0 and -2. And likewise here for the cos, you see that it has a variable of a half, numerical value of a half, being added to the trigonometric function. So it's been elevated in the y direction. And so here again, notice the brackets. Okay, this means that the degree, okay, or the radian is now affecting the theta. So when we add something, it's shifted to the left, and again when we subtract something, it's shifted to the right. And you can see here that you can sketch the graphs of sine n, theta n, and tan n theta, appreciating this rule. Okay, so we have the scale factor of 1 over a when we have this equation, and in the special case where a is -1, this is equivalent to a reflection in the y-axis. An example of this that we saw was with this question here where we had minus tan theta. Okay, and so you have some other examples that you can work out through here, and then we come on to the mixed exercises. And the point I should highlight here is what we've already discussed. We mentioned about the coordinates. Please get yourself accustomed and familiarized with this, and then you also appreciate some of the rules here. Here you have some properties that again you should also memorize using the mnemonic method. And here you have properties as well of angles, appreciating the equalities between the two properties with their respective angles. Now this is something that if you have time you should memorize. If not, don't worry about it too much yet. It's just giving you a shortcut to appreciating what the trigonometric function is with respect to a particular angle, giving it to you in radians. But you have a calculator, so you can do it on a calculator. And then again, just some of the things we mentioned earlier on about the periodicity, and again you just have these special rules here and useful properties. So do remember what the variables or the numerical values and their effects, i.e. the transformations on the graphs, and you'll be sorted for this particular chapter. So that's the end. Thank you very much for listening. We'll see you for our next videos. Take care and goodbye.